processes are a crucial unit operation in chemical engineering. They are mainly used in mixing and homogenization of fluids and gas dispersion. Also, they are especially important in cosmetics and food industries for emulsions fabrication. A Ruston turbine is a specific type of impeller which is originally designed with 6 flat vertical blades, although new versions with a different type or a different number of blades have been studied. Baffles are flat blades which are attached all along the inner walls of the tank in order to remove swirling and to promote fluid movement in a vertical way. The two most important dimensionless parameters in the analysis of a stir tank are the Reynolds number and the power number.
For the simulation, it was necessary to develop a simple mesh. However, because of the complexity of the blades, it was necessary to develop a thinner mesh in this region. Also, an Aurelian multiphase method was used in order to analyze the behavior of the two fluids used, as it was honey and water. Kappa omega was used in order to predict the behavior of the fluids in turbulent and transition region. A rigid body motion method was used in order to predict the rotation of the blades, and it is necessary to know that this body motion does not require an perfect mesh and is used in unsteady state. So, for the volume fraction of the liquid used, it was necessary to develop a field function, a position field function.
In the volume fraction for a stir tank without baffles, as shown in the animation, the velocity profile of the fluids tend to be organized, which creates the vortex. As the blender starts its motion, the velocity profile immediately shows an increase in its magnitude in the areas around the blades. Due to this increase related to the rotation of the blades, a momentum transfer is shown around them in which velocity increases outwardly. Finally, a vortex is made over the blades where the highest velocities are obtained at closer distances from its center and decrease as it approaches the tank walls.
As for the honey, the interface behaviors are similar to water, in which a vortex is formed. They show that although honey presents a higher viscosity, the ascent of bubbles inevitably results in an organized flow pattern and, as a consequence, in a vortex.
As the velocity profile shows, a maximum speed is obtained in the innermost part of the tank. As displayed in water, this zone presents the highest velocity of all, due to the no-slip conditions assigned to the first liquid layer adjacent to the wall.
Between both water and honey, it can be seen that the change in the properties of the fluid did not affect the volume fraction or velocity profiles, because both showed and displayed the formation of a vortex due to the swirling phenomena. This could be solved using an adequate and symmetric number of baffles, which turn this swirling motion into a desired flow pattern with a high degree of mechanical stability. The CFD is a useful tool to predict physics phenomena with some degree of uncertainty, as although it does not take into account every aspect that happens in real life, it shows a close approximation which is highly useful in order to choose or discard some design variables. Accuracy and precision of computational simulations require a great amount of time. For this, it is necessary to select the parameters of the simulation reasonably in order to find an equilibrium between accurate and time-saving.